Okay, so today we're going to be looking at day 4, which is going to be graphical transformations. So we're going to see how different values in the equation can make different types of transformations happen. So the transformations that we're going to be talking about. So first off, we have horizontal or phase shifts. So when you have in your parentheses an x plus a constant, so x plus a c, this means you're going to you're going to shift left c units. Okay, so when it's x plus c in the parentheses here. We're going to be graphing. So when we graph, this means you're going to subtract this value from x. Okay, and we'll give you lots of examples of what this is going to look like in a second. And then if it's x minus c, that means we're going to go right c units. So then when we're graphing, we're going to add to x. Okay, so just an example that you can see for what I'm talking about here. If I have f of x equals x plus 7 squared. Okay, that's quadratic because of the squared. This plus 7 tells me that I'm going to have a transformation moving left 7. Okay, it's the opposite of what you would think it is in here. So the plus 7 is left 7. The reason is because if you solve x plus 7 and set it equal to 0, that gives you negative 7, which means left 7. So let's say I have absolute value of x minus 3. Okay, that's an absolute value function. But because of this x minus 3, because it's minus 3, it's really going to mean you're moving right 3 spaces. Okay, so then we have vertical shifts. So on the outside of the parentheses, so f of x plus d tells you you're going to move up d units. So when we're doing this graphically, that means we're going to be adding to y. And if you have f of x minus d, so minus d on the outside, that means you're going to move down d units. And then when we're graphing this, that means you're going to subtract from y. Okay, so let me give you an example of that. So let's say we have x cubed plus 8. This is a cubic function. Because this plus 8 is not in the parentheses, it's on the outside, this means you're going to be moving up 8 spaces. And then, let's say we have absolute value of x minus 7. Because this is on the outside of those absolute value bars, the minus 7 tells us we're going to move down 7 spaces. Okay, so then we have reflections. So for the reflection, if the negative is out front of the f of x, then it's going to reflect over the x-axis. Okay, graphically, you're going to switch the signs in y. Okay, the reason is if you reflect, think about if you reflect over the x-axis, if you reflect from this point to reflecting over here, you're really changing those y values, okay? And then if it is, the negative is on the inside of the parentheses or the absolute value bars, then you're going to reflect over the y-axis, which means you're going to switch the signs of x. Okay, so let me give you an example of that. So let's say we have f of x equals negative x to the 5th. Okay, the negative is out front, so that means we're going to reflect over x, the x-axis. And then let's say we have negative, I'm going to throw some, I will just say negative x to the 3rd, which we could really bring that out front. Let me Let me do a different type of example, just because that one you can simplify. What if we have, so if we have like an exponential and we have e to the negative x. So that negative's not out front, it's inside of the e. So because of that negative inside the e, that means it reflects over the y axis. Okay, so a way I remember this, x comes before y, so if the negative's out front, it reflects over the x-axis, and if it's the second one here in the inside, it reflects over the y-axis. So we have move left and right, up and down, and then we have our two reflections. So the other transformations that you need to know are when we have stretches or shrinks. So if you have y equals c times f of x, so c is a constant here. If c is greater than 1, then you're going to have a vertical stretch by a factor of c. If the c value is between 0 and 1, then you're going to have a vertical shrink. And you might see the word compression instead of shrink. Either word could be used here by a factor of c. So what you're going to do graphically, no matter which one it is, you're going to multiply by, you're going to multiply the y value by that value of c, whatever it is. Okay, so example of that, f of x equals 4x squared. So this 4 out front, because it is bigger than 1, we have a vertical stretch. And then if we had f of x equals 1/4 e to the x, so that 1/4 out there, because it's between 0 and 1, that would give us a vertical shrink, and also known as a compression. Okay, so then if that c value or that constant is inside of the parentheses instead of on the outside, then that's when we're working with horizontal shrinks or stretches. Now these are a little confusing. I'm going to put a star beside it because these can get a little tricky sometimes. But this c value is really going to be thinking about the opposite. So if c is greater than 1, then that means you have a horizontal shrink by a factor of 1 over c. Whereas if c is between 0 and 1, then you have a horizontal stretch by a factor of 1 over c. So it's the opposite of these rules over here. Okay, so let me show you what that means, and then we'll talk about graphically. So if we have f of x equals, in our parentheses, we have 3x squared. Because that 3 is in that parentheses, this is going to mean that we're going to have, it's going to be horizontal. And because it's a 3 here, you're actually thinking about that it's really referring to as 1/3. So it's actually going to be a horizontal shrink. And it's going to be a horizontal shrink by a factor of 1/3. Okay? So the way I think about it, if I see a whole number here, I just think, oh, it needs to be the reciprocal. So if I see 3, I think 1/3, and so that has to be a shrink. Whereas if we have f of x is the absolute value of 1/5 x, like that, that 1/5, so because it's on the inside, it's horizontal. That 1/5 makes me really think about 5, so it's a horizontal stretch by a factor of 5. Okay, so if it's on the inside, remember how for left and right you had to do opposite. So if it's on the inside and it's a number there, you want to think about the reciprocal. So if it has a 3, you're really thinking about 1/3. 1/3 will be a shrink. So 1/5, you're really thinking about 5, so it'll be a stretch by 5. Graphically here, we're going to multiply the x value by 1 over c. So whatever this 1/3 or 5 there is what you would be multiplying by. Okay, so when you're graphing these, the steps that we're going to take, so you're going to make a table of the parent graph. So the parent graphs are the graphs that we focused on in day 3. So we have our linear graphs, our quadratics, absolute values. You're going to make a table of the parent graph. And you're going to make a new table, and you're going to make sure you do your stretches or shrinks first. Stretches or shrink first. Then you're going to make another table, and you're going to make sure you do the reflections next. And then after you do the reflections, then you can do any shifts. So anywhere you move left, right, up, or down. So you have to do stretches or shrinks first, then reflection, then you can do your left, right, up, or down. And then finally you can plot your points from your final table, and that'll give you what your graph's going to look like. So that's how we're going to be looking at transformations.